Hi everyone, welcome back. And today we are going to see about the flow sensors in HVAC applications. Okay, so and flow sensor or flow meters, which are the devices which are used to measuring the flow rate of the fluid or it may be a gases. So the flow rate can be defined as the volume of fluid flowing through an area in unit time. So in a pipe, the flow rate can be expressed in terms of speed of the fluid and with respect to the cross-sectional area of the pipe. So these are the two parameters to calculate the flow. One is with respect to the velocity of fluid or gas, another one is with respect to the cross-sectional area. So these are the few classifications of the flow meter, like the abstraction type, inferential type, electromagnetic type and anemometer. Okay, so in an abstraction type flow meter, okay la, so the flow passage of the liquid or it may be a gas, so the pressure drop across the obstruction is measured, so the pressure drop is converted into the electrical signal, so that here we can able to measure it directly. So such as orificimeter or venturi meter or flow nozzle, so some of the flow meters can be used to measure and calibrate the flow rate. And this is the orifice meter. So this type of flow meter and orifice plate is placed inside the pipe. So there is it will be placed inside the pipe. So just now you can consider this is an pipeline. So across the pipeline, this orifice is placed inside the pipe. So there is an obstruction in the flow of fluid or it may be a gas. So because of this obstruction, we may able to calculate the pressure drop across the orifice and we can able to measure the flow rate. So here the pressure is while we are placing this orifice plate inside the pipeline, the pressure is dropped suddenly when the fluid passes the orifice and continues to drop until vena constricta is reached. So the result of the increase in velocity of the fluid passing through the reduced area. And so here we can able to measure it. Here just we can see, here we can able to measure. So here now you can imagine this is an obstruction, or if it's the obstruction, and here we may feel here the pressure is very high because the obstruction is created. So the water or gas pressure is high. So here only the little amount of water or gas will be leaked in this gap. So here the pressure is very low. Now we can compare these two pressures. Now here we can compare the pressure 1 and pressure 2, the before the orifice and after the orifice. So the difference between the two pressure, it can be measured, and this pressure signal is converted into the electrical signal, so that we can able to measure what is the flow rate across the pipe. And this is the anemometer. So here an anemometer, a hot wire anemometer, is a temperature transducer using for the measuring flow rate. Okay, so now you can consider, so this is a pipeline. So here one ceramic tube is there. Here there is a two conducting wires are there. There are two conducting wires are there. It is made of this is an ceramic cement. Okay. So when electrically heated, the temperature sensor is placed in a floating fluid. The heat transferred from the sensor to the fluid. So hence the temperature of the sensor reduces, resulting in change in resistance of the wire. So the amount of cooling of the wire, it depends on the flow velocity, and hence the resistance variation can be measured to measure the flow rate of the fluid. Okay. So what is the advantage? It can be used for fluids with a rapidly fluctuating velocity and relatively low cost. And this is the electromagnetic flow meter. So in this type of electromagnetic flow meter, which is used to measure the flow of the fluid. So here now we can consider this is a pipeline. Here there is a flow of water or it may be gases there. So here now we are passing the electromagnetic waves, electromagnetic fluxes across the flow of water or gases, and because of this obstruction, Okay, so here we are keeping the two electrode across the pipeline. So here we are passing the electromagnetic waves. So because of this electromagnetic waves, the flow of fluid or water gases, so there is a distortion in the fluxes. So that here, because of this distortion, we are measuring the voltage across. We are measuring the voltage across the electrode. So the measured output voltage can be converted into the workflow rate. Okay. So, this is the assessment. May know which fluid has lowest density, whether the acetic acid or the pure water or the olive oil, or it may be a seawater. So put your answer in the comment section. And these are the few textbooks for this particular topic. Thank you.